you know that having the right tools and knowing how to use them can save you time and improve the quality of your work? The multimeter or Volt-Ohm meter is one of the handiest tools you can have in your tool pouch. There are a variety of multimeters available. There are analog and digital meters. The analog uses a meter movement while the digital uses a numeric display. Both work the same way. They read AC or DC voltage and resistance from two external leads. These leads plug into the meter based off which voltage or resistance you want to read. To make your job easier, we recommend you always have a binding post adapter, which will allow you to connect directly to a coaxial connection for accurate readings. The binding post adapter has a BNC type connection, so you'll always need a BNC to F connector to connect it directly to our RG6 connectors. Though the scales on multimeters may look intimidating, they're easy to use if you know what you want to read. Let's say you need to find out if an IRD is putting out enough voltage to power the LNB. By turning the selector to the DC voltage setting for 0 to 20 volts DC, the meter is ready to check output voltage. The leads need to be in the common or ground plug and the DC voltage plug, then connected to the binding post adapter following the color code. Remember, black is ground and red is hot. Now connect the coax jumper between the IRD output and the binding post adapter. Your meter display should be reading about 18 and 13 volts. The voltage should be alternating between 13 and 18 while the IRD searches for satellite signal. If you're reading an alternating voltage of 13 to 18 volts, the IRD is working just like it should. To see if the voltage is getting to the LNB, we reconnect the cable from the dish to the IRD, then check voltage at the LNB. By disconnecting the cable at the LNB and connecting to our multimeter the same way we did behind the IRD, we can determine if the voltage is reaching the LNB or if there's something wrong with the drop. It's important to remember that doing this only detects an open or a short. It does not detect voltage drop conditions. An inline voltage measuring tool such as a meter is needed for this. Also keep in mind that there is voltage loss through the RG6 cable, so the voltage we read at the LNB will be lower. We should see the fluctuation between the 13 and 18 volts just like we saw behind the IRD. Since there's no load on the line, the voltage reading will be slightly higher than it would be if the LNB was being powered. We can read the voltage loaded using the dual buddy. To do that, we connect the dual buddy in line using a jumper. Next, we select the current voltage setting. The voltage will display on the LEDs. This is the actual voltage powering the LNB. If the voltage is less than 15.5 volts, there's either too much cable in line, a bad section of cable, or a bad connection. The LNB will not switch between polarities. Remember that RG6 with a solid copper center conductor has less resistance than the RG6 with a copper-clad center conductor. RG59 has even more loss. That means the length of cable can be far less using either copper-clad RG6 or RG59. DirecTV requires all HSP installations be done using approved RG6 cable with a solid copper center conductor. We require solid copper because of the approved voltage drop. So what happens if there's a good voltage at the IRD but none at the dish? There could be a break in the cable or a short. When the cable is broken, it creates a condition we call open, and when the center conductor is making contact with the shield, we call it a short. To test for a short, first make sure the cable is disconnected at both ends. This test can only be done between the segments of cable that do not have active components such as switches and amplifiers. Using a standard multimeter, set it in the ohm setting. You're looking at resistance. Touch the two leads together at one end, and the meter should read 0 or short at the other end. When you separate the leads, you'll read infinity. Now connect the binding post to the cable at the dish or multi-switch if one is in line. If there's any reading other than infinity, there's a short in the cable. Though we've tested and found no short, an open condition or break could still be in the cable. To test for an open, go back to the IRD location and connect a shorted connector or a terminator to the cable. If you use a shorted connector like this one, the reading at the other end of the cable should be 0. Exactly what you read when you touch the two leads together. If a terminator is used, the reading should be 75 ohms. Keep in mind that there are about 2 ohms of resistance per 100 feet. If you read infinity, there is a break in the cable and an open condition exists. Look for bad or loose connectors or cuts in the cable. To effectively troubleshoot, you need to isolate the problem to a particular section of the cable. Go to the ground block and check again. This will let you know exactly which section of the drop has the fault so you can correct it. It's not uncommon for animals to chew through a cable, which can create either a short or an open. Though we usually think about dogs chewing cable, rodents do more damage than dogs. If there is damage from rodents, try to attach the replacement cable in a way that it doesn't expose it to damage. Keep it off the ground and attach tightly to the building. Using these tools, you can get your job done better and faster. I'm Patrick with DirecTV. Have a great day.